So we're in section 6.2. We're talking about the law of cosines. Again, you guys have seen law of cosines a couple of times. So we're going to do a couple of things with it, kind of a refresher on law of cosines. Now, just as a reminder, when we use our various rules. So law of sines. We use law of sines. We use law of sines when we're given the combination angle side or angle side angle. And these are the nice ones where we always have one triangle. These two will always give us one triangle. Where we have to be careful is when we're given the combination side-side angle. This is when we have the ambiguous case. So when we have side-side angle, that's our ambiguous case, where we could have 0, 1, or 2 triangles. We use law of cosines for our other possible combinations of sides and angles. So our law of cosines is when we're given side, 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 or side, angle, side. That's when we use the law of cosines, when we're given those combinations. If we're given 3 sides or 2 sides and the included angle. And law of cosines is always going to give us one triangle. But there's one thing we have to be a little careful about, and we'll talk about that. All right, does everybody have that part? So law of cosines, I'm not going to show where the law of cosines comes from. We use a distance formula. It's not a really hard thing to show, but it has to do with dividing our triangle into right triangles, kind of like we did with the law of sines, the little example we did with law of sines yesterday, where the law of cosines comes from. If you're interested, there's a proof on page 469 of the textbook. It's not difficult, and it's actually kind of interesting to look through where the law of cosines comes from. So for the law of cosines, we're just going to write down what it looks like. We'll draw our triangle so we have it to refer to. So our triangle, here's our oblique triangle for law of cosines, and we've been labeling it A, B, and C. And this is side A, side B, and side C. Law of cosines we can write it in 3 different forms. They're really the same thing. It just depends on which sides and which angles you're given. So if we are given side, angle, side, we can use the law of cosines in this form. A squared equals B squared plus C squared minus 2BC cosine A. We can also write B squared equals A squared plus C squared minus 2AC cosine B. And our third form is c squared equals a squared plus b squared minus 2ab cosine c. So if we're given two sides and the angle between them, that's what side angle side means, the angle is between the two sides, we can solve for the other side using law of cosines in this form. Now let's take a look at this real quick. What if we had a right triangle? What if A was 90 degrees? What if angle A was 90 degrees? What's the cosine of 90 degrees? What's the cosine of 90 degrees? 0. Cosine of 90 degrees is 0. So if we ignore this, what do we have? If this whole part is 0, we just have a squared equals b squared plus c squared. What's that? That's the Pythagorean theorem. So if we have a 90-degree angle, the law of cosines just turns into the Pythagorean theorem. So law of cosines are related to the Pythagorean theorem. It still works when, if we have a 90-degree angle, it just turns into the Pythagorean theorem. So this is kind of an extension of the Pythagorean theorem. So if we have side angle side, we can use the law of cosines in one of these three forms to find the missing side. And then we can, once you find the missing side, then you can use the law of sines to find the other two parts. It's a lot easier to use the law of sines than the law of cosines because this is involves a little more calculation. And we'll do an example in just a little bit. Now if we have a side-side-side combination, if we have three sides, we need to find angles. So what we do if we have three sides is we solve each of these for the cosine of the angle. And we can use that to find our angles. So when we solve for the angles in each of these, we get that the cosine of A is b squared plus c squared minus a squared over 2bc. And we do the same thing for the other combinations. We can say that the cosine of b equals a squared plus c squared minus b squared over 2ac. And finally, we get for the cosine of angle C, we can say that that is a squared plus b squared minus c squared over 2ac. I'm sorry, 2ab. So if we're given side angle side, we can use it in the first form. If we're given side side side, we can solve for one of the angles with the second form. Now where we have to be careful with the law of cosines is with side side side, you always want to solve for the biggest angle first. Want to solve for the biggest angle first, and that'll avoid the reason we solve for the biggest angle first is because we start with the law of cosines and then we go to the law of sines. When we use the law of sines, when you plug in the inverse sign in your calculator is only going to give you an acute angle for the inverse sign. But sometimes that biggest angle is obtuse. It's more than 90 degrees. And you'll run into problems because your calculator won't tell you that. Your calculator will only tell you the acute angle. So that's why we solve for the biggest angle. The biggest angle is opposite the biggest side. So when we have a side-side-side combination, you want to solve for the biggest angle first, and that's going to be opposite the biggest side. And that way you'll avoid problems with your calculator giving you an angle that you don't want. Any questions on the form of the law of cosines? And Ms. Cunningham and I talked about it, and we decided that for these things, that we would probably, on a test, we would probably write these on the board, so you don't have to memorize all the different forms. All right, let's do a couple of examples. We have, let's say we're given that C is 111 degrees. A is 27. Side A is 27. And side B is 18. We want to find the side and the two angles. So we're solving the triangle. So let's do a quick sketch of our triangle, just so we know what it helps us see what we're looking at. And I'm just going to draw it this way, A, B, C. And we know that this is 111 degrees. And this is 18. Side B is 18. Side A is 27. And this is side C. So we have side, angle, side. We have two sides in the included angle. So this is a side, angle, side. So we can use one of those first forms of the law of cosines to find our missing side. So we're just going to plug our numbers into the law of cosines. We know that law of cosines tells us that c squared equals 18 squared plus 27 squared minus 2 times 18 times 27 times the cosine of 111 degrees. When we plug this into our calculator and calculate, we end up with c squared equals about 1404.33. And we take the square root and we say that c is about 37.43. Because we don't have a 90-degree angle. You can only use a Pythagorean theorem when you have a 90-degree angle. If you don't have a 90-degree angle, you can't use a Pythagorean theorem. Okay, that's a good question. So now we have side C. Side C is 37.43. We could use law of cosines again, because now we have three sides, but now it's going to be way easier to use the law of sines. We have side C and angle C. We can find angle A, and then once we find the second angle, we can subtract, add those together, subtract from 180 to get our third angle. So let's find angle A. We're going to use the law of sines now. We know that the sine of A over 27 equals the sine of 111 degrees over what we just found for side C, 37.43. This tells us that the sine of A is 27 times the sine of 111 degrees, all divided by 37.43. We can find, this tells us that the sine of A is, when we plug that into our calculator, sine of A is 0.673. take the inverse sine of 0.673, and we get that A is about 42.3 degrees. And then to find the last angle, now we have two of our angles. To find our third angle, we just add 42.3 to 111, subtract that from 180 to find our third angle. So once we have two angles, finding the third angle is really easy. Does that make sense how we did that? Any questions on using the law of cosines? We're going to do an example of the side, 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 and then we'll talk about another area formula. So let's do a side, side, side example. So for this one, we know that A equals 5, side A equals 5, side B equals 8, and side C equals 7. So this is side, side, side. We need to find angles. So we're going to use that second set of equations that we came up with for the law of cosines to find our angles. So I'm going to we'll draw a quick sketch. The sketches will help you work on what we're talking about. So this is side A is 5, side B is 8, and side C is 7. So our triangle looks like this. It's not necessarily to scale, but we have an idea of what we're working with. Now on the side, side, side combination, we want to find the biggest angle first. We're going to find the biggest angle. The biggest angle is opposite the largest side. So the biggest angle is going to be angle B. So we want to find angle B. We're going to find that one first. So we're going to plug into our formula. We know that cosine of B, using our formula from the law of cosines, is 5 squared plus 7 squared minus 8 squared over 2 times 5 times 7. I'm just plugging into the law of cosines. So cosine B is about 0.143. Find the inverse cosine of that to get our angle. Yes. You got what now?
103.
Did you subtract the 8 squared?
I don't know if my calculator might do that stuff because it's still
Oh, you did. You have 85 squared. All right. So B comes out to be, when we do the inverse cosine, B comes out to be about 81.8 degrees. So now we know one of our angles. This is 81.8 degrees. Once we find one of the angles, once we find one of the missing pieces using law of cosines, now we can use law of sines. It's way easier than using law of cosines again. We could use law of cosines again. It involves a lot more calculation. So now that we have one angle and one side opposite, we can use the law of sines. So let's use the law of sines to find angle A. So I'm going to say that the sine of A over 5 is the sine of 81.8 degrees over 8. So this tells us that sine A is 5 sine 81.8 degrees over 8. And we calculate that, we get sine A is about 0.619. So A is the inverse sine of that. So A is about, angle A is about 38.2 degrees. Now we have two of the angles. We can add those together, subtract from 180 to get our third angle. And we'd have all the information in that triangle. Questions on this? Everybody good with law of cosines? So we don't have to worry about the ambiguous case. That makes us nicer to work with. But just remember, when you have the side-side-side combination, to find that biggest angle first. All right, the last thing we're going to look at is another area formula. Oops, I want one of these. This is called Herons Formula. Heron was lived in Greece at about 100 BC, and he worked with he was very interested in finding areas of different shapes. He worked with triangles and all the way up to like huge number of sides on polygons, trying to figure out how we find areas. But using the law of cosines, Heron was able to develop this angle formula. And our formula is, I'm going to give you the formula and then we'll talk about what the parts are. The area of a triangle is S times S minus A. And these are S's, not 5's. Times S minus B. Times S minus C. And we have, and this is for a triangle with sides A, B, and C. And S is called the superperimeter. S is A plus B plus C divided by 2. So if we know 3 sides of a triangle, we can use Heron's formula to find the area. And this one is pretty straightforward. And the problems just are going to involve plugging numbers in, finding S and plugging numbers in. So I'm not going to do an example of this one. This one's pretty straightforward. So we now have three formulas for the area of a triangle that we, depending on what we're given, we have 3 different ways to find the area. So our first one we talked about a little bit yesterday, 1/2 base times height. The second one that comes from the law of sines, 1/2 AB sine C. That's one of the formulas that we talked about yesterday. And then we have Heron's formula. So depending on what information you have about a triangle, now you have 3 different ways that you can calculate the area of the triangle. Any questions on what we've done so far? All right. Homework. There you go.